Hello everyone, this is Mayuk Mazumdar and I'm back with another exciting session. So let's proceed.
This is the final session on Flask, and this session will be more or less more theoretical than and less practical. So, to begin with, the final remaining components of Flask, the first that we have in hand is extensions. Flask is often referred to as a micro framework because a core functionality includes WSGUI and routing based on WorkZeek and template engine based on Jinja 2. In addition, Flask framework has support for cookies and session as well as web helpers like JSON, static files, etc. Obviously, this is not enough for the development of a fully fledged web application. This is where the Flask extensions comes in picture. Flask extensions give extensibility to Flask framework. There are a large number of Flask extensions available. A Flask extension is a Python module which adds specific type of support to the Flask application. Flask extension registry is a directory of extensions available. The required extensions can be downloaded by the pip utility. In this tutorial, we will discuss the following important Flask extensions. The first that we have is a Flask mail, which provides the SMTP or simple mail transfer protocol interface to Flask application. Then we have the Flask WTF, which is used which adds rendering and validation of WT forms. Then we have the SQLAlchemy, which adds SQLAlchemy support to Flask application. And then we will be exploring Sijax, Flask Sijax, which is an interface for Sijax, Python or jQuery library that makes Ajax use easy to use in web application. Each type of extensions usually provide extensive documentation about its usage. Since an extension is a Python module, it needs to be imported to be used. Flask extensions are generally imported as Flask foo. To import, we can simply use the from Flask foo import Flask or comma function. Now for versions of Flask greater than 0.7, you can also use the syntax from flask.txt import foo. For this usage, a compatibility module needs to be activated. It can be installed by running flask_compact.py. So from that we'll be importing, and over there we'll be activating or calling the activate module, and then from flask_ext we'll be importing a foo package. The first of the extension to begin with is the mail extension. Now, a web-based application is often required to have a feature of sending mail to the user or client. Flask mail extension make it very easy to set up a simple interface with any email server. At first, Flask mail extension should be installed with the help of pip utility, and we can install it simply using the pip install flask mail command. Then, Flask mail needs to be configured by setting values of the following application parameters. We have a list of 11 parameters and their description, what they do. First, we have the mail server, which will be associated with the name or IP address of the email server. Then we have the mail port for the port number of the server used. Then the mail used TLS to enable or disable the transport security layer encryption. Then mail use SSL to enable or disable the security socket layer encryption. Then the mail debug for the debug support. Default is Flask applications debug status. Then we'll have the mail username, that is the username of the sender, the password of the sender. Then the mail default sender, which sets default sender. Then the mail maximal, that sets maximum mails to be sent. Mail suppress sent, sending suppressed if app testing is set to true. And mail ASCII attachments, if set to true, attachment files converted to ASCII. Now, the Flask mail module contains definitions of the following important class. The mail class. It manages email messaging requirement. The class constructors takes the following form, that is flaskmail.mail and within parentheses app equal to none. The constructor takes the Flask application object as a parameter. The methods of the mail classes are listed over here. There are three methods: send, connect, and send message. Send is used to send content of the message class. Connect is used to open connection with the mail host, and send message is the send message object. Then the next is message class. It encapsulates an email message. Message class constructor has several parameters, as in over here: subject, recipient, body, HTML, sender, CC, BCC, reply to, date, corset, extra headers, mail options, RCT options. Then we have the message class methods. The first one is attach. It sends an attachment to message. The method takes the following parameters. One is file name, content type, data, which is the raw file data, and disposition. Then we have the add recipient method, which adds another recipient to the message. Now, in the following example, SMTP server of Google Gmail service is used as mail server for Flask mail configuration. The first step that we have to do is to import mail and messages class from the Flask mail module in the code. Over here, we have imported the corresponding requirements. The second step is to the Flask mail is configured as per the following settings. That is, we have the mail port, we have the mail username, which should be your Gmail username or any username. Since we are using smtp.gmail.com, so we believe that the username should be a Gmail one. Then we have the mail password. Then we are specifying whether to use TLS and SSL, true or not. Now, the next step is creating an instance of the mail class. Okay, now over here we create an instance of the mail class by using mail equal to mail of app. So I believe I have just configured that. Yeah. Now the first step was to importing, and there is some issues with my syntax, so it should have been from Flask mail import mail comma message. That was the first step, that is to import the module. Then we have to configure the following settings, and once the configuration is done, we have to create an instance of the mail class, and finally when it's done, then we have to set the message object in a Python function mapped to this router / or whatever you may be your endpoint. And finally we have the entire script. Let me uncomment and show it to you. So over here I'm importing the required modules, and then I'm configuring my smtp.gmail.com, the mail server. Once it's done, I'm creating an object of the mail class, and then I am just defining a route which will send me a mail. Over here the message is hello, the sender will be my mail ID, the recipient will be the recipient's mail ID, and the message body is hello Flux message sent over Flask. So using this code snippet, you can also try and send email via Flask, but I have not given my user ID or password over here, and so this is the code snippet that's required, but I won't be showing you any practical example in this scenario. The next we have is Flask WTF. Now, one of the essential aspects of a web application is to present a user interface for the user. HTML provides a form tag which is used to design an interface, as I have shown you in my previous examples. A form element such as a text input, radio, select, etc. can be used appropriately. Data entered by a user is submitted in the form of a HTTP request message to the server-side script by either GET or POST method. The server-side script has to recreate the data, the form elements, from HTTP request data. So, in effect, form elements have to be defined twice, once in HTML and again in the server-side script. Another disadvantage of using HTML form is that it is difficult, if not impossible, to render the form elements dynamically. HTML itself provides no way to validate a user's input. This is where WT Forms, a flexible form rendering and validation library, comes handy. Flux WTF extensions provide a simpler interface with this WTF forms library. Using Flux WTF, we can define the form fields in our Python script and render them using an HTML template. It is also possible to apply validate to the WTF field. Let us see how this dynamic generation of HTML works. First, the Flux WTF extension needs to be installed, that is by using pip install Flux WTF. The install package contains a form class which has to be used as a parent for user-defined forms. WT form package contains definitions of various from fields. Some standards of the form fields are listed below over here and their corresponding descriptions. You can get a look at it. Now, for example, a form containing a text field can be designed as below. So I'm importing that, and once the importing is being done, let me uncomment it and you will get to know a better picture. So over here I've just imported the required extreme imports, and then I've just created a class, and over here just by using the text field from the package WT form, I am defining a text field that name of the student, what it should be. In addition to the name field, a hidden field for CSRF token is created automatically. This is to prevent cross-site request forgery attack. When rendered, this will result into an equivalent HTML script. Over here, this just simple one line is equivalent to this HTML script. Now let me comment it out and then proceed. A user-defined form class is used in a Flask application, and the form is rendered via a template. The code snippet over here. So over here I have defined a user-defined form, and I am rendering some HTML to do so in this using this code snippet. Now, WT forms package also contains validator classes. It is useful in applying validation to form fields. Following list shows commonly used validators. Some of them like data required, and it can't be empty. Email, since it should be of time@something.com or something. Then we have the IP address checker, validates whether the entered field is an IP or not. Then definite length of input field is required. The number range, that means should be in a given range. Suppose you have been asked to enter something in between 0 to 10 and you are entering some 100. So these validations will be there. There is also URL validator, which identifies whether the valid URL is entered or not. So these are some of the validators. We shall now apply data record validation rule for the name field in the contact form. Over here, just as I showed you name of the student, over here I am saying that validation required by this format. Now, the validate function to form object validates the form data and throws the validation error if validation fails. The error message are sent to the template. In the HTML template, error message are rendered dynamically. In my HTML component, in this manner, the errors will be rendered dynamically if any validation error happens. The following example demonstrates the concept given below. The design of the contact form is shown here. Let me uncomment my script and then I will explain you the components of it. Over here I am importing the record packages and then I have defined the application. Now here you will get to see that there is a class contact form. So what it does, it has various text fields, radio fields, options that I have defined the form basically over here in this class. Name, gender, address, email, age, language, and then there is a submit button. So now I am defining a /contact endpoint. Over here I am creating an object of this class, and once it's done I am checking if the method type is post or not. Then I am validating that whether all means if there is an error, then I'm validating all fields are required using the flash that I've shown you in my last class or last session. and then I'm rendering some HTML, that is contact.html, that I have over here. So what it does, this contact.html, it basically renders the errors that if any, and then the form it is defined over here, and then it creates a form action to my /contact endpoint over here. And if there is no error, then it returns that the form has been posted successfully. Otherwise, if the method is get, then also it renders the contact.html. Now let me run this and you will get a better picture of the scenario that I am explaining. So my application is running on localhost 5000 and I am making a request to the contact endpoint. When I do so, I'll get to see that the contact form has been rendered, and this have been rendered dynamically from here. I have defined all the fields and all the validations over here, and then I'm using this contact.html, the form, to iterate over all my elements that I have, and then to give us this UI over here. Now I'm completing this address with my corresponding address, my details, and then I've entered my email as well. Let me enter my age, and then I'm selecting the language and then click on the send button. Since all the elements are successful, there is no error in that, so no issues have been found. Now let me refresh it and create an now I'll be putting some details as wrong. Suppose I'm not entering my complete email address, or suppose I'm anything random other than integer. I'm selecting, and then I'll click on the send button. Then I'll get to see that please enter your email address. Okay, now let me give proper email address, but my age will be now will be a non-integer. And even if I click on this, nothing happens. There is an error. This is because this field accepts only numeric field. So if I click on send again, have I done anything wrong? Oh yeah, no. When I click on send, then yeah, form have been posted successfully. So this is how we can use Flask WT forms to render a form dynamically as per our use case. The next topic that we have in hand is SQLite. So we all are aware of what is SQLite. If not, it's basically an instance of a SQL. It's a category of a DB. Now Python has inbuilt support for SQLite. SQLite 3 module is shaped with Python's distribution. For a detailed tutorial on using SQLite database in Python, you can visit some quite well-known sites such as W3 School or Tutorials Point. They're quite friendly and quite helpful. I've learned from there as well. So in this section, we'll see how a Flask application interacts with SQLite. Now, initially, we should create a SQLite database named as database.db, and then we'll create a student table named as students in it. So this can be easily done using this code snippet where I am importing the package SQLite 3, and then I am this is coded in Python 2, so that's why you get to see these things. Now I'm just creating one, making a connection to my database.db, and then I'm executing one create table syntax. So once this is done, we will be good to go. Now I will not execute this one because I won't be requiring that. Now our next task would be to import the requiring our Flask to import the corresponding required modules from here. Let me uncomment my code snippet at first. So you got the idea that I'll be inserting data into a SQLite instance, that is the database.db. So for that, what my code snippet will look like. So this is the required imports, and the application forming is done. Now I've defined a route, that is add record or add rec. So this route, what it does, it extracts from the request content that it receives on the request body. So it will now extract those, the name, address, city, and the pin, and then
will insert into the tables to will create with will connect with the SQL database, and then with the cursor, using the cursor, it will execute on one SQL statement. And our SQL statement is insert into student, the field names and the column names, and the values will be the variables that we have extracted just now from the request body. And once it's done, it will the connection, it will make a commit, connection.commit. Now this connection is the SQL.connect connection instance that we are connecting while with the database. Once it's there, it will commit all the changes, and once the commit happens, then it initializes the code snippet, initializes the message variable with record successfully added. Otherwise, if any error happens in between, then it will roll back all the modification, or suppose there is an error at one state, so it will roll back, and the modifications won't be updated in the DB, and it will initialize the variable message with error in insert operation. And finally, whenever either the data gets inserted over here or some error happens over here, the finally block will be executed, and it will be used to close our connection, the one that we have opened over here. So it's a good coding practice, or I would suggest you to always close the connections that you are opening while scripting. So once it is done, now I have defined another application which will list all the contents of the elements in the database. So it populates rows as a multi-linked object containing all records in the student table. So over here I am creating a connection object, and then I am using the connection.row factory to define the SQL.row factory, SQL.row. So I am prepared this object, and now I am connecting with the I'm creating the cursor object, and then I am executing that select star from the students. So with this in my cursor, all the components will be extracted, and using this fetch all, I am using this fetch all attribute or module, I am fetching all the contents of my cursor that it holds. That means selector from student, that all the data that we already have in my table are now being fetched by using this fetch all. Now once it's done, it renders it to the list.html all, and the rows will be the rows that it has fetched. So in this manner you can connect to a DB, SQLite DB instance, then insert data into it, and then fetch the data from it as well. I won't be demoing this one example as a practical. The next we have is SQLAlchemy. Now, using raw SQL in Flask web application to perform CRUD operations on database can be tedious. Instead, SQLAlchemy, that is a Python toolkit, is a powerful or mapper that gives application developers the full power and flexibility of SQL. Flask SQLAlchemy is the Flask extension that adds supports for SQLAlchemy to your Flask application. Before that, let me give you a definition of ORM. What is ORM, or object relation mapping? Most programming languages platforms are object oriented. Data in RDBMS servers, on the other hand, is stored as tables. Object relation mapping is a technique of mapping object parameters to the underlying RDBMS table structure. An ORM API provides method to perform the CRUD operation that without having to write raw SQL steps. In this section, we are going to study the ORM technique of Flask SQLAlchemy and build a small web application. Our first step is to install the Flask SQLAlchemy extension over here. The next step will be to import SQLAlchemy class from this module. The third step involves to create the Flask application object and set URI for the database to be used over here, the database of the SQLite table or SQLite instance. Now, the fourth step is to create an object of a SQLAlchemy class with application object as the parameter. The object contains the helpful functions for ORM operation. It also provides a parent model class using which user-defined models are declared. In this snippet over here, a student model is being created. See, I've defined a class db, and then with the parenthesis db.model. db is an object of SQLAlchemy, and using the db.model, I've defined a model for student class. Now, the fifth step is to create the URL to use database mentioned in URI and run the createAll method. Once the definition is done, then we can use the createAll method to create the database. The session objects of SQLAlchemy manages all persistent operations of ORM object. The following session methods perform the CRUD operation. One is db.session.add, one is db.session.delete, and one is model.query.all. The db.session.add inserts the record into the map table. The delete one deletes the record from the table, and the model.query.all retrieves all records from the table corresponding to the select query. Now you may apply a filter to the retrieve record set by using the filter attribute. For instance, in order to retrieve records with city equal to Hyderabad in students table, use the following statement: students.query.filter by within parentheses city equal to Hyderabad.all. With this much of background, now we shall provide a view function for our application to add a student data. So in this manner, you can use SQLAlchemy, and you can use the Flask SQLAlchemy feature. So now the entry point of the application is show all function bound to the /URL. The record set or of the students table is sent as parameter to the HTML table template. The server-side code in the template renders the record in the HTML file form. Now let me uncomment my code snippet and explain it to you. So over here, as I said, I have defined the application object, means I have imported the required one. So once the import is done, then the Flask application object is have been set over here. After that, we are setting the URI of the database that's required. We are also setting the secret key. Then we are creating object of the SQLAlchemy class using the application object as a parameter. Over here, the application object as a parameter. Once it's done, we are creating a model for the with the name student. Once the model is done, we are now defining our routes. That is, the first one is to show all, and then we are creating new. So for the new one, we are extracting from the request body. Once the extraction is done, we are adding the component, means the values to the model student that we have defined. Once it's done, we are committing all the changes, and after that we are rendering the new.html, which is again the form to insert the new values into my HTML table. And then once it's all done, in the main class I am defining the db.createAll method, and I am running the application. So in this manner, you can use Flask SQLAlchemy to interact with the SQL instance and perform operations on it. The next component that we have in hand is the Sijax. So before we use that, we have to install this package, and to install we can easily simply use the pip install Flask Sijax method. However, Sijax stands for Simple Ajax, and it is a Python or jQuery library designed to help you to easily bring Ajax to your application. It uses the jQuery Ajax to make an Ajax request. I already told you about the installation, and it's quite easy by simply using pip install Flask Sijax or pip install Flask Sijax. Now the next thing is configuration. Sijax static path. The static path where you want the Sijax JavaScript file to be mirrored. The default location is static. Over here you'll get to see static/js/Sijax, and within this the folders are being stored. So this is the by default static path, the Sijax static path. The default folder location is static/js/Sijax. In this folder, Sijax.js and json2.js files are kept, as you can get to see. The next one configuration is the Sijax JSON URI. That is the URI to load the JSON to JS static file from. Now Sijax uses JSON to pass the data between the browser and the server. This means that the browser needs either to support JSON natively or get JSON support from the JSON2.js file. Functions registered that way can provide Sijax functionality because they cannot be accessed using a post method by default, and Sijax uses post requests. The next component that we have is a deployment, and which is the very final component and is an important one. Now, externally visible server is the first topic that we'll discuss about. A Flask application on the development server is accessible only on the computer on which the development environment is set up. This is a default behavior because in debugging mode, a user can execute arbitrary code on the computer. If debug is disabled, the deployment server on local computer can be made available to the users on network by setting the hostname to app.run host equal to 0.0.0.0. Thereby, your operating system listens to all public IPs. The next topic is deployment. To switch over from a development environment to a full-fledged production environment, an application needs to be deployed on a real web server. Depending upon what you have, there are different options available to deploy a Flask web application. A small application, you can consider deploying it on any of the following hosted platforms, all of which offer free plan for small applications. Some of them are Heroku, .cloud, Webfaction. Flask application can be deployed on these cloud platforms. In addition, it is possible to deploy Flask app on GCP or AWS or Azure anywhere. Local tunnel service allows you to share your application on localhost without messaging with DNS and firewall settings. If you are inclined to use a dedicated web server in place of the above mentioned shared platforms, following options are there to explore as well. The first one is the mod WSGI. Mod WSGI is an Apache module that provides a WSGI compliant interface for hosting Python-based web applications on Apache server. To install the mod WSGI, we can install it directly from the PyPy release. You can simply use pip install mod WSGI. To verify that the installation was successful, run this script mod WSGI start server. This will start up the Apache/mod WSGI on port 8000. You can verify the installation worked by pointing your browser to localhost 8000. Now, you have to create your WSGI file. There should be your application.wsgi file, maybe anything you would like to name, but there should be that application name.wsgi file. This file contains the code mod WSGI which executes on startup to get the application object. For most applications, the following file should be sufficient. From your application, import app as application. Make sure that your application and all the libraries that are in use on the Python load file. The next that you have to do is configuring the Apache. You will need to tell your mod WSGI the location of your application, and using this setting you can let you know. You'll just have to let the address of the application and then the path of the WSGI file and what are the things you would like to allow or deny, blah blah blah. So once these settings are done in this manner, you have to set your Apache to let know that the location of the WSGI file. Standalone WSGI containers are there. There are many popular servers written in Python that contains WSGI application and server HTTP. Some of them are Unicorn, Tornado, Gvent, Twisted Web. Unicorn is quite popular and is used by all or most. The next concept that we have is the Fast CGI. Fast CGI is another deployment option for Flask application on web servers like Nginx, Lite HTTPD, and Cherokee.
For configuring the first CGI, first you need to create the first CGI server file. Let us call it your application.firstCGI. So over there, you just have to import and put this contents like this, that from Flask server.fcgi import the WSGI server, then as I said, your application.fcgi file, you have to import the app, and then if the name is equal to main, then using this point wsgi server.app of app.run. So using this you can configure the first CGI server file. Now Nginx and other versions of light HTTPD needs a socket to be explicitly passed to communicate with the first CGI server. For that to work, you need to pass the path to the socket to the WSGI server, and this can be done over here. WSGI, whenever making an object of the WSGI server, you have to let know the application name, the bind address, that is the path to the socket file, and then .run. Then you have to configure the Apache. For a basic Apache deployment, your .fcgi file will appear in your application URL. Example, suppose example.com/yourapplication.fcgi/hello. These are a few ways to configure your application so that your application.fcgi does not appear in the URL. You can simply let your server name, then example.com, then the script alias is the path to your application.fcgi file, and then you can substitute with the script alias and use it to define the path. Remember to enable the first CGI alias and rewrite models. This configuration binds your application to /your application. So these are the few deployment features that I have discussed about, and in this entire course we have discussed over the various components of Flask and the enormous power that it has to make wonders. I hope you have liked all of this session on Flask. Thank you. Have a great day.